Hello, we are the Mesh Network team. I am Honeycutt.
I'm Kurt May.
And I'm Henry Dzruko.
Our advisor was Kevin Myers and our client was Victoria Walters. Here's a brief presentation of our project.
Throughout recent history, cyber attacks and natural disasters have been occurring more often each year. In these situations, people are left without access to a network, unable to communicate rescue efforts with each other. It is crucial in the first 72 hours that the person gets rescued, or else their chances of survival significantly drop. It also takes rescue officials multiple hours to arrive on scene, if not longer, to help. We designed the emergency mesh network to combat all these problems. Using affordable, off-the-shelf components, we designed the network to be built by anyone in various situations to communicate across a space determined by the amount of nodes they make. The network can be deployed in a matter of minutes and controlled by the central PI.
To combat this issue, we designed an affordable off-the-shelf IoT device that can be implemented with DJI drones to create an emergency mesh network. The device consists of a Raspberry Pi 4B acting as the brains of our device, a Halow module, which is 802.11ah, which is the mesh network protocol, and a Pi sugar, which is used for powering the entire device itself. Along with this, we also have a sub 1 GHz antenna used for the Halow protocol. We picked Halow over LoRa because Halow is a relatively new protocol, and it's significantly better in data rate and as well as penetration for objects such as concrete buildings or trees. The way that our project works is that we have one device on the ground acting as our access point. This device will link up with the remaining devices, which are being flown in the air by DJI drones, as you can see here. The Pis are securely attached to the drones with these 3D printed parts. These parts were designed by the Honeycutt Middle School. Essentially, someone will be walking underneath these drones, and they'll be able to connect to the emergency mesh network. When connected to the network, a captive portal will open up, showing this screen here. On this screen, it will let you know that you're connected to the emergency mesh network, and here you're able to submit whatever your emergency is, where you're located, and your name. From there, the message will be transferred between the drones all the way until it gets back to the access point, in which emergency responders will be able to receive your message.
Through testing, we were able to conclude that the Halow protocol would be a viable solution to our problem, as it can maintain high bit rate while penetrating through buildings. Unfortunately, due to time restraints and poor weather conditions, we were unable to do practical testing with the drones active. So far, the team has been able to build multiple nodes for the network, but we struggled to connect both the sub 1 GHz network from the Halow module and the 2.4 GHz network with the Pi together. Potential improvements to be made in the future would be to implement push notifications to alert users that they are in range of the network. As our time to work on this project comes to an end, we can conclude that if we were given slightly more time to configure the network properly, this project could be implemented. But as of now, it remains a proof of concept.